In this tutorial, I will explain in detail how the time-based one-time password algorithm works. This tutorial is not specific IOTA related. It is intended for developers who want to understand how the time-based one-time password algorithm works. An application can implement several methods for the user to authenticate itself. Method A. What the user knows, for example, using username and password. Method B. What the user has, for example, a device to generate a one-time password, meaning a token. Method C. What the user is, for example, using fingerprints or face recognition. In a one-factor authentication, an application often implements method A. In a two-factor authentication, an application often implements method A and the second method, B or C. In a three-factor authentication, an application often implements method A, B, and C. The Trinity desktop and mobile wallet allows you to set two-factor authentication. This will add an additional security layer to prevent unauthorized access to the wallet. There are many two-factor authentication apps which you can install on a mobile device, such as Google Authenticator and Authy. Google Authenticator and Authy both implements the same time-based one-time password algorithm. The time-based one-time password algorithm generates single-use passwords, also known as tokens, which are only valid for a certain time period. Often this time period is 60 seconds. These generated tokens are based on a shared secret key. The time-based one-time password algorithm was published as RFC 6238 by the Internet Engineering Task Force. For more information, see this link. In RFC 6238, a Java reference time-based one-time password algorithm can be found. See this link for this Java file. The time-based one-time password algorithm is an extension of the HMAC-based one-time password algorithm, which was published as RFC 4226 by the Internet Engineering Task Force. The HMAC-based one-time password defines an algorithm to create a one-time password from a shared secret key and a counter. For more information, see this link. When two-factor authentication is enabled on the Trinity wallet, it first generates a shared secret key. This is the generated shared secret key. You must write down this shared secret key and safely store it. Usually, this shared secret key with additional information is embedded in a QR code which you can scan by a two-factor authentication app such as the Google Authenticator. Let's assume you have installed the Google Authenticator on a mobile. After the QR code is scanned, the Google Authenticator generates a token which is a unique code based on the shared secret key and the current time. As you can see over here, this is the generated token. And this is additional information. Here's another example. This is the generated token. This is the issuer name. And this is the account name. The question is, how is this token generated? I will now explain in detail how this token is generated on a mobile device. Let's assume you are currently in Beijing, China. The local Beijing date and time is 4 December 2018, 20 hours, 24 minutes and 20 seconds, UTC +8. The date and time at that moment at 0 degrees longitude meridian, that is this line, is 4 December 2018, 12 hours, 24 minutes and 20 seconds. UTC stands for Coordinated Universal Time and is a time at the 0 degrees longitude meridian, also known as prime meridian, as you can see over here. Convert this date and time, that's this date, 4 December 2018, and this time, 12 hours, 24 minutes and 20 seconds, to Unix epoch time. Instead of Unix epoch time, we can also say Unix time. Unix epoch time is the number of seconds that have elapsed since January the 1st, 1970 at 00 hours, 00 minutes and 00 seconds UTC, not counting leap seconds. If the date and time at 0 degrees longitude meridian is 4 December 2018, 12 hours, 24 minutes and 20 seconds, then the Unix time is this value. If we look at this equation, n is the number of time steps which have been elapsed since Unix epoch time. Floor is a function which rounds a number downwards to its nearest integer. The Unix time is the number of seconds that have elapsed since January 1st, 1970, 00 hours, 00 minutes, and 00 seconds UTC, not counting leap seconds. And this represents a time step. By default, the time step is 30 seconds. If this is our Unix time, then this is the number of time steps which have been elapsed since Unix epoch time. This point represents January 1st, 1970, 00 hours, 00 minutes, and 00 seconds. From this starting point, we take a time step of 30 seconds, as you can see over here. This is our first time step. We start with value 0. The next time step, we increase our value, as you can see over here, is 1. The next time step, the value will be 2, 3, 4, etc. These values are Unix times, and these values are the number of time steps since Unix epoch time. If we focus on this area, then this line represents 4 December 2018, 12 hours, 24 minutes, and 00 seconds, which has this Unix time. This line represents 4 December 2018, 12 hours, 24 minutes, and 30 seconds. This is a 30-second time step. And this line is 4 December 2018, 12 hours, 25 minutes, and 00 seconds. And this is the corresponding Unix time. Again, the time step is 30 seconds. So in this time step, the value n is this value. And in this time step, the value n is this value. So 4 December 2018, 12 hours, 24 minutes, and 20 seconds has this value n. Convert the number of time steps into a hexadecimal value. The hexadecimal value must have 16 hexadecimal characters, meaning 8 bytes. If not, prepend with zeros. So this was our value n, and this is the value converted into a hexadecimal value, prepended with zeros to make it 16 characters long. Now convert the hexadecimal value into an 8 bytes array and assign this value to variable m, short for message. Next, convert the shared secret key, this key, into a 20 bytes array and assign this value to variable k. The shared secret key is a randomly generated 20 bytes number which is base 32 encoded. For readability, this key is divided in groups of 4 characters and all in lowercase, as you can see over here. More information about base 32, see Blockchain Tutorial 31. See this link. Calculate the HMAC hash using the HMAC-SHA-1 algorithm. The HMAC-SHA-1 algorithm uses as input the message and variable k as input and outputs the HMAC hash. More information about HMAC, see Blockchain Tutorial 30. See this link. This HMAC hash size is 160 bits, meaning 20 bytes. Let's assume this is the HMAC hash value. As you can see, it is 20 bytes long. Now get the last 4 bits of this hash value and get its integer value. In this example, the last 4 bits is this hexadecimal value, which represents integer 10. This integer is called the offset. Starting from the offset, get the first 4 bytes from the HMAC hash. The offset was 10, as you can see over here. Then we take the first 4 bytes. Next, apply a binary operation for each byte. For this first byte, we apply this binary operation. And for the other 3 bytes, we apply these 3 binary operations. The new binary value is this. Convert this binary value to an integer, as you can see over here. Now calculate the token. That's the integer value from the previous slide, modulus 10 to the power of n, where n is the token size. In this example, the token size is 6. As you can see over here, this is a token size, 6 digits. So the token is then the integer value modulus 10 to the power of 6 is this token value. If this calculated token has less than 6 digits, prefix it with zeros. And this is how a token is generated. So every 30 seconds, a new token is generated. At time 0 seconds, a new token is generated. At time 30 seconds, a new token is generated. But each new token will remain valid for 60 seconds. If you look at this token will remain valid for 60 seconds, as you can see over here. After 60 seconds, it becomes invalid. The same applies for this token. This token will remain valid for 60 seconds. If you have installed the Trinity desktop wallet and have enabled two-factor authentication, make sure your computer has the correct date and time set. The same applies to the mobile device where the two-factor authentication app is installed, for example, Google Authenticator. Instead of scanning the QR code, you can manually enter the shared secret key in the two-factor authentication app, but it is not recommended because you might make typing mistakes. An example of a shared secret key generated by the Trinity wallet looks like this. If you manually enter the shared secret key in a two-factor authentication app, you can enter upper or lowercase letters with or without spaces. A two-factor authentication app will convert all entered characters to uppercase and will remove all spaces. The actual shared secret key only contains the letters A to Z and the digits 2 to 7 because it is base32 encoded. An online time-based one-time password generator can be found at this location. It behaves the same as the Google Authenticator or Authy. This application also demonstrates how the token is validated. Warning: do not use this tool to generate your tokens. It is only intended for educational, test, or demonstration purposes. This is my time-based one-time password generator. I have created this generator for educational, test, or demonstration purpose. Do not use this generator to create your tokens. You can enter an issuer name and you can enter an account name. If you press this button, Create Shared Secret, it will generate a shared secret key and a QR code containing this information. As you can see, every 30 seconds, a new token is generated. As you can see, a new token is generated. I open the Google Authenticator app on my mobile phone and I'm scanning the QR code. And as you can see, both tokens on my online web tool and on the mobile phone are the same. This is my Trinity wallet. Let's log in. Let's enable two-factor authentication. Copy this shared secret key. And press this button, Use known shared secret key. And you can enter this token. And now you enter your password. And as you can see, two-factor authentication is now enabled. Let's write down this token. I wait till this token changes. As you can see, the token has changed. But we know that this old token will be valid for 60 seconds. And as you can see, two-factor authentication is now disabled. So this is the proof that the token will be valid for 60 seconds. But every 30 seconds, a new token is generated. Thanks for watching. I hope you enjoyed the video. Please hit the like button and don't forget to subscribe. If you have questions, leave your comments below. I'll do my best to answer them.